So today we will do permutations and combinations, and then we will quickly cover the binomial theorem. Okay. So let us go through permutations and combinations quite quickly. Okay. So permutations means arrangement of things. Okay. Permutation is nothing but arrangement. Is arrangement. And so, what is the difference between permutation and combination? Okay, combination is not an arrangement. So, combination means selection of things. Okay, so I give an example. Suppose I am saying I am writing a word rose. Okay, so this rose, it can be written as rose like this. Okay, so you can write it as O-R-S-E. Okay, similarly, you can, how you will write, I will tell you. Okay,
your order matters.
So here R you have written, the second can be, okay, the second can be O-S-E. Okay, then the third can be like R-O fixed. So now you are left with
S and D.
So you are left with two only, S and D. Okay. Okay. So now after three are fixed, you are only left with one. Okay. So you can see here. So this also will be fixed with this and this and this. This also will be fixed with something and this and this. So how many, finally how many it is? 1, 2, 3, 4, 5, 6. Okay. So this is for R. So this is 1. You start with R, you end up with 6. Clear? You start with R, you end up with 6. If you start with R, you end up with 6 different permutations. Okay, 6 different arrangement. Otherwise, similarly, you start with O, go like this, and then so let us say O means this is S,
R or E.
R S E. Okay, R S and E. Okay, so with this you have only two. So this and this. With this you have only two. This and this. And then this and this and this. Right?
Yeah.
This is another 6. Okay. So likewise with R, with one character you are arriving at 6 arrangements. With the second character, another 6 arrangements. Similarly with S, another 6 arrangement. With E, another 6 arrangement. Okay. So how many? So if somebody asks you to create an arrangement of the characters in the word rose. Okay. If this is the case, how many will the arrangement? 6 plus 6 plus 6 plus 6. Okay. So that is equal to 24. There can be 24 arrangements. Okay.
Yeah.
So this is how do you get 24? This 24 is nothing but 4 factorial. Okay. So you know 4 factorial is nothing but 4 into 3 into 2 into 1. So that is called 4 factorial. Or otherwise this is a permutation. Okay. So this is permutation where we write it as NPR. Okay. So here your N is, so your N is 4. Okay. Your N is 4 and your R is 1. You are taking one letter at a time.
Yeah.
So this is NPR. So which is 4P1, which is like NPR is equal to n factorial divided by R factorial.
Into n minus r factorial. That is for combination.
That is for combination. So this is for n minus r factorial. Okay. So this becomes 4 factorial divided by sorry, you are taking 4 at a time.
Time, so it becomes 4pr.
4P4. You are taking 4 at a time. You
4p4.
So you have 4 members, you are taking all 4 at a time.
You are taking 4.
So it becomes 4P4. So 4 minus 4 factorial. Okay. So this becomes 4 factorial by 0 factorial.
Which is 1.
Which is 0 factorial is 1. So 4 factorial by 0 factorial, which is 4 factorial, which is 4 into 3 into 2 into 1, which is 24. Clear? So now you can understand what is permutation. Okay. So permutation is an arrangement. So if you take word rows and you are taking all 4 characters and you are arranging it in whichever manner you want. So if you start with R, there will be 6 arrangements. If you start with O, there will be 6 arrangements. Likewise, there will be 24 arrangements. Okay. So that's why that 24 arrangement is nothing but your NPR. So N is equal to 4 here, R is also equal to 4. Okay. Suppose somebody asks you to take three characters out of 4
P3.
and then do the arrangement. So that will become 4P3. Okay. So 4P3 will become 4 factorial divided by 4 minus 3 factorial into 3 factorial. Right? N minus R into R.
No, that is for combination.
Sorry, okay. So 4 minus 3 factorial. Okay. So if you take 3, right?
Yes.
So this will become 4 factorial divided by 1 factorial. Again it will be the same. Okay. 4 minus 3 is 1 factorial, and if you take 2, 4 out of 2, it will become 4 factorial divided by 4 minus 2 factorial, right?
Yeah.
So which is 2 factorial. So 4 divided by, so 4, 3 into 2 factorial divided by 2 factorial. So this becomes 12. So if you take 2 out of 4, 2 characters out of 4 and you arrange it, so you will end up in 12 combination of that, 12 arrangements you will end up with. Okay. So you take a picture. Okay. So this one is permutation, but combination means, so this rows you write it whichever way you want. So ROSC, ORSC,
Will all be the
or
same.
EO, RS, whichever you want, it is all same. This is one group. Actually. So combination is nothing but selection, or that's one group. Like
in combination, order will not matter.
So in combination, order does not matter. So in this case, combination formula will be NCR, which will be n factorial divided by r factorial into n minus r factorial. So you are like 4C4, okay? That will be 4 factorial divided by 4 factorial minus 4 factorial, okay? So this becomes 4 factorial by 4 factorial. That means what? 1.
One way.
Okay. So now you understand, like you can write rows whichever way you want to write. It will be one only.
Considered as one.
So it will be one group, but it will be 24 arrangement. So permutation is arrangement, whereas combination is a group or a selection.
Yeah.
Okay, that's the difference between permutation and combination. Okay. Take. Okay, so now you understand what is permutation, what is combination. So now after understanding the basics, it's all about practicing as many as possible. There can be a number of numericals which can, a number of questions which can be asked. Okay. One thing is like n factorial is equal to n into n minus 1 into n minus 2. Okay, so likewise it will go on and it will end up with 1. So that is your n factorial. Okay, so another property of factorial is 0 factorial is equal to 1. That is another thing we need to remember. Okay, factorials of negative integers and factors are not defined. Okay,
Yeah.
so no factorial real of negative integer of or factors. Okay,
Yeah.
so that is another property. Okay. Then n factorial. Okay, so then permutation is the arrangement of thing, and NPR that we have done already. NPR is equal to n factorial by n minus r factorial. That is permutation. And then something called NPN. Okay, so NPN is nothing but n factorial divided by n minus n factorial. So which is equal to n factorial by 0 factorial is equal to n factorial. So this is NPN is nothing but your n factorial. Okay.
Like that 4p4.
Okay, so there are different properties of this permutation that you can do. So there are different properties that you can look at it. You can practice as many as possible. Okay, so the number of permutations of n different objects. What does it mean? Okay, this means the number of permutations or arrangements, number of permutations of n different objects taken r at a time. That is called permutation. Okay. Then there is permutations when all the objects are not distinct objects. Okay, so let us say permutations when all objects are not distinct. Okay, so let us say I am writing ROOT. Okay, so here these two characters O are not distinct. They O is repeating. Okay, so in this case, because now if all are distinct, it will give rise to, suppose there are n characters, so it will give rise to n factorial arrangement. Like earlier we say 4 factorial rows. Okay, rows, it has 4 factorial, so it is 4 into 3 into 2 into 1, so 24 arrangements we had, right? But now if you go to a word root, okay, here what will be the number of arrangements? So the arrangements, this O, it will repeat. So in that case, the number of arrangements will be n factorial into this. How many repetitions are
2.
there? So this is 2 factorial. So it will become 4 factorial divided by 2 factorial. Okay, so that is if there is repetition. Okay. You can take a picture. We'll do some numerical. Okay. Okay. So how many four-digit number can be formed using the digits 1 to 9 if repetitions of digit is not allowed? Okay. So you have digit 1 to
9.
1, 2, 3, like this you have 9 digits. Okay. The question is how many four-digit numbers can be formed by using the digits 1 to 9, okay, if the repetition is not allowed, okay. So four-digit number, so it will be kind of N, P, R, so here N is equal to 9, R is equal to 4. So it will be 9, P, 4. So, this is the four-digit number. So these many ways four-digit numbers can be formed by using digits 1 to 9. 1 to 9. Okay. So by using digit 1 to 9. Okay. So that's NP4. Like say you are taking say 1, 2, 3, 4. Okay. Then 4, 3, 2, 1. Okay. So these are like say or 6, 7, 8, 9 or 9, 8, 7, 6. All these things matter. So that's why whether this may be a same group,
But
it
the
is a
order
different
is
arrangement.
different.
Different arrangement.
Order of numbers arranged is different.
So suppose you are saying there are 11 players, okay. So no, suppose you want to form a cricket team. You have to select 5 bowlers out of you have an option to choose 5 bowlers from 7 bowlers. Okay, so that will be a combination. So I'll choose 5 bowlers from 7 bowlers. I have 7 bowlers. I have to choose.
Here their order will not matter because they
Here
are
order will
distinct
not-
objects.
Distinct object. It's a group. Okay, so I have to choose 5 bowlers out of 7 bowlers. So that case it will become 7C5. So that will be a combination. Okay.
Your repetition
Haan.
and like the order in which they are
So
selected
this is
matters in
arrangement.
permutation.
So this is arrangement, whereas this is a group.
Group.
Arrangement, whereas combination is a group. Okay. And one more important thing is when number of permutation of n objects where, so let us say you have n objects, okay, you have n objects, okay, out of n objects, so p1 objects are of one kind, p1 objects are of one kind, p2 objects are of another kind,
Okay.
are of another kind. So in that case, so what will be the permutation? Okay. So the number of permutation of n objects where p1 and p2 are of second kind and all that. So in that case, this is p1 means these are repetitions.
Understood.
So in that case, the answer will be n factorial divided by p1 factorial into p2 factorial. Right? Like that. So if there is repetition, you have to divide.
This was there now. Similar question.
Yeah. If there is a repetition, you have to do. It will reduce because what I was.
This will be used in probability also. Same kind.
Yes. Yeah. This permutation combination is used in probability.
Bayes
also.
theorem and Bernoulli's tales. Combination is used in Bernoulli's.
You have to look into those things again.
Yeah.
Okay. Whatever I have studied on probability, 3D geometry.
Second year, fifth year.
So root, I was telling, it will be 4 factorial divided by 2 factorial. How will arrange? Whether you write O at the front or the back doesn't matter. It will be the same arrangement. Because so if there is a repetition, how many times it is repeating, that you divide by n factorial, you divide by that. Okay, so basically this is all about permutations. Okay. There are some other, tricky things in permutations. These also may come. Okay. So number of permutations of n different things taken are at a time when a particular thing is to be always included in each arrangement. Okay. So each the number of permutations of n different things taken are at a time, n things taken are at a time, okay, and the condition is one particular thing. Out of n things, one particular thing is to be always included in each arrangement.
Okay.
So you will say that one particular thing will always be included. Out of n thing, you are fixing one thing.
Okay.
So in that case, what will be the permutation? Okay. In that case, the permutation will be R into n minus 1 factorial, n minus 1 p r minus 1. So you are fixing one thing.
Okay.
So your n is becoming n minus 1, r is becoming r minus 1. But you have to multiply it by r. So this you have to remember. Okay.
Okay.
Suppose you want to make a permutation of r things out of n things, where one of the thing will always be there.
Yeah.
In that case,
one thing is constant, the other order.
So n minus 1 p r minus 1 into
like
r.
Like in rows, r will always be in the first position, but the other three can be interchanged.
So because one thing is fixed, so you have now liberty to choose from n minus 1 and r minus 1. So n minus 1 p r
out
minus
of 4,
1.
the other three can be changed, but suppose r position is
fixed. Suppose I am
fixed.
saying rows. Okay. So now I am saying my rows.
Only 3 letters can be arranged,
so
one will be fixed.
In every combination, r will always be there. Okay.
Understood.
So if r is always there,
only
it is already
3 are
fixed.
left.
Then you are fixed with like say.
N will become 3 and r will become 3.
Yeah. So n things you are taking r at a time. Okay. So you are taking r at a time. So 4. R is 4, n is 4. But 1 is fixed. Let us say r is fixed. So in that case, it will be 4. Okay. 4 then 4 minus 1 p 4 minus 1.
3p3.
Okay. So 4 into 3p3. If you are
4
fixing
into
one.
3 factorial.
Yes. So that is one tricky thing. Okay. So these are all there. So these tricky things only will come in the examination. Okay. So now another one is number of permutations of n different things taken are at a time when a particular thing is never taken in each arrangement. Suppose here one particular thing is always considered, but you imagine you are not taking r at all.
Only the OIC are taken.
So number of permutation of n different things taken are at a time when a particular thing is never taken in each arrangement. So that will become n minus 1 PR. Okay. So you are left with only 3 things. Okay. So you are ROSC. So you are never going to take R out of it. So
only 3 are left.
Only 3 are left. So it will become 3. Okay. 3. Suppose
out of 3, how many ever you are selecting.
So it will become 3P3.
If you are selecting all 3, it will be 3. If you are selecting 2, it will be 2.
3P.
It cannot be 4.
It cannot be 4. R cannot be 4. So you are removing the possibility of R altogether. So it will become 4 minus 1 3. 3P3 is the maximum thing. It can be 3P2 depending on whether
how many you are selecting.
Yes. So that is another thing. Okay. So that is excluding. That is
when one is not selected.
Always
one is rejected.
Exclude one of them.
Yes.
Okay, so this is another tricky thing. So another one is the number of permutations of n different things taken are at a time allowing repetition. So if you allow repetition, then it will become n to the power n. Okay. Sorry, n to the power r. Okay. So I think there was a there is some. Yeah. So this is. There is allowing repetition. So I have seen one numerical here where they had allowed repetition. Okay. Mm. Okay. So what does it mean? What does it mean? Like, suppose suppose you have a word number. Okay. You have a word called number. Okay. So here nothing is. You have a word called number, and you are here. You have 6 digit. Okay.
Yeah.
So here you have 6 digit. So when repetition is not allowed, suppose I want to take 3 numbers out of 6, so it will be 6p3. Okay. So it will be 6 factorial divided by 3 factorial into 3 factorial. Okay.
No.
So this is, yeah,
factorial
sorry,
by
this is
3
permutation. Okay. 6 minus 3 factorial is 3 factorial. Okay. So this will be 6 into 5 into 4 into 3 factorial divided by 3 factorial. Okay. So 120 ways. Okay. So if you want to make an arrangement of 3 characters out of these 6 characters, there will be 120 ways.
And
But
6 are
but if you allow repetition, like say I can only write NER, okay, or I can write NBR. Okay, so here I am not allowing repetition.
No.
But if you allow repetition, say I write NNR,
Okay.
that means you have allowed the repetition
One
of one of the
character to
characters.
be repeated.
If that is the case, in that case the number of ways it can become is 6 to the power 3.
Okay.
Okay, so that is like 216 ways.
Understood.
216 ways. So this is also important.
Understood.
So when you are taking 3 out of 6, but you are allowed to repeat it, it will become
n to
n
the
to the power r.
r.
So when it will become n to the power r,
If repetition
if,
of one character
if
is
it
allowed.
is repeated. Okay, so that is also an important observation.
Understood.
then that is n to the power r. Okay, so one is r into n minus 1 p r minus 1, another is n minus 1 p r. So when you are completely excluding
Including
one
one.
thing, okay, uh, and
Making sure one is constant, making sure one is not included, and one more case is
n to the power r.
if it
When
is
they
repeated,
repeat it,
repetition
okay,
is allowed.
yeah. And then another important one, the permutation of n thing of which p are identical. So permutation of n things of which p are identical of one, q are identical of the second set, r are identical. That's what I am
By
taking.
2 factorial.
So you are taking n things out of which p set, p identical set. Okay.
So n factorial by p.
Q identical set, R identical set. In that case, the permutation will be n factorial
by p
factorial, Q
into
factorial,
r
R factorial. So this is
If there are like root only one letter is repeated, so only p factorial. If r r o o is there, p and q factorial.
yes. So these whatever is there here, these 4 points, these is remember. These tricky questions only will come. Okay, so we are done with permutation. Now we'll get into combination. Okay, so yeah, so I have already explained you what is combination. So you take a snapshot of this, then we will get into combination. So now you understood what is permutation. Okay. Permutations and then we get into combinations. Okay, so combination, what I was telling that it's a group, it's not an arrangement. Okay.
Order does not. Order
Order does not matter
matter.
here. Okay. Order does not matter. So like I was telling you, you have 7 bowlers, you want to select 5 bowlers. In how many ways
Only
you can
one
select?
way.
Yeah. That is C7, 7 C5.
7 c5.
Yeah. Combination. So I have already given you one example of rows. So you have your n is equal to 4 here. Okay. You want to form a arrangement of 4 characters. So
Only
in that
one.
case, sorry, you want to form a arrangement means it will be NPR, but if you want to form a group,
it will be combination.
so it will
NCR.
be R is equal to 4, so it will be a group, so it will be NCR.
4CR.
4CR.
Which is 4 factorial
by
4 factorial into
4 minus
4
0
factorial.
factorial.
4 minus 4 factorial, which becomes 0 factorial.
Okay, let us see. So it will be n factorial divided by r factorial into
n minus r factorial.
Okay. So this become n
4
factorial divided by
4 factorial.
4 factorial, then 0 factorial. This is one only.
Yeah.
So from rows you can make only in one way you can make one group. Okay.
One group.
So that is the meaning of combination. So formation of a group. Okay. So this card problem actually you can form like what I had explained you in probability.
I know.
This card concept.
Face card, diamond, I know that.
So
That is used in
yeah, just
Bernoulli's
we'll
also.
do one numerical that will give you a idea. Okay. So. Okay, there are some inferences of combination. Okay, so NCR. Okay, n minus r. Okay, so n minus r is equal to NCR. Okay, so that is one inference. Okay, NCR. Okay. So if NCA is equal to NCB implies A is equal to
B.
Okay, that is. Then another theorem is NCR plus NCR minus 1 R minus 1 is equal to N plus 1 CR. Just remember this. You can derive it, but just remember. NCR plus NCR minus 1 is equal to N plus 1 CR. So here there is one numerical. If NC9 is equal to NC8, okay. So they have given if NC9 is equal to NC8,
what is
okay,
it?
then find NC17. Okay, find NC17. Okay. So that's the question here. So first we will equate these two things. Okay. So n factorial by 9 factorial n minus 9 factorial. Okay. Is equal to n factorial by 8 factorial n minus 8 factorial. Okay. So this becomes kind of so n factorial divided by 9 into 8 factorial, right?
Yeah.
Okay, then this become n minus 9 factorial. Okay. So then it implies, okay, then n factorial by 8 factorial, then n minus 8 into n minus 9 factorial is what?
N factorial will get cancelled.
Okay, so no, n minus 8 factorial is equal to n. Okay, n minus 8 factorial is equal to n minus 8 into n minus 9 factorial, right? Right? Because
n minus 1, yeah.
So n minus 8 factorial is equal to n minus 8 into n minus 9 factorial. Okay, right?
Yeah, correct.
So this becomes n minus 9 factorial here.
That will get cancelled.
So your 8 factorial cancels. N minus 9 cancels.
N factorial numerator also
cancels. Okay, so this become 1 by
n
9.
minus 8 is equal to 9.
1 by n minus 8, right?
Yeah.
So n minus 8 is equal to 9.
So
okay.
n is
equal to 17. Okay, so what they have asked? 17 C17. Okay.
Which is 17 factorial.
So 17 factorial divided by 17 factorial. Which
that
is
only NC and
yeah. Equal to 1. So so the catch
NCN
here
is equal to n factorial.
So the catch here is n minus 8 factorial is equal to
n minus
8 into n minus 9 factorial. This you need to.
That n factorial formula they told
minus
it
1.
will go up till 1. At the end it will.
So it will get reduced by 1. So n factorial equal to n into n minus 1 into n minus 2 like that. So if you want to put it a break, okay, n minus 8 factorial is equal to n minus 8 into n minus 9 factorial. So that cancels out and you get it. So you got n17 is equal to 1.
Yeah.
Okay, so that's a tricky numerical in NCERT book. You can those things also can come. Okay, so now committee or group, that is more related to combination, right?
Yeah.
So there is a question: a committee of 3 persons is to be constituted from a group of 2 men and 3 women. So you have 2 men, you have 2 men and 3 women, right?
So n is 5.
So let us see. A committee of 3 persons is to be formed from a group of 2 men and 3 women. In how many ways this can be done? Okay. So here order does not matter. No. Okay. So therefore we need to
same
count,
like cricket. Like
yes.
So 5
So here we need to count combinations. So there will be as many combinations as there are
people.
There are combination of 5 different persons. Okay.
From 5 people, 3 have to be taken. So 5C3.
So your total n is equal to 5. And you
R
are
is
going
equal
to
to
choose 3 out of 5. Okay. So you are going to choose 3 out of 5. So this will become
5C3.
5C3. Okay. So you have 5 available.
3
and
have
you
to
will
be
take
taken.
3 out of that. Okay. So it doesn't matter actually whether in this whether men are there or women are there. But if you go deeper and say that okay, I need these many men, these many women, then it will be still a little bit tricky. Okay. So now let us say
It will become addition. You'll take one.
So you can choose three people from 5 people group in 5C3 ways. Now let us get into the details. Okay. Now the condition applies. Suppose you want to form a group in which there will be one man and so there will be one man and 2 women. Okay. So you want to form a group. The group, a 3-member group, will have one
One man,
have,
2 women.
One man and 2 women. Okay. So it will have one man and 2 women. Okay. So see, this one man can be selected from 2 men in how many ways?
2C1.
2C1 ways. So these 2 women can be selected
3C2.
from 3 women in
3C2 ways.
3C2 ways. Okay.
Okay.
So these two. Therefore, the required number of combination will be. So this will be a multiplication. Remember, this is not a addition. This will be a multiplication.
In combination, it is multiplication.
So first you are selecting in two women, 2 men, one man you are selecting out of 2 men in these many ways. Then you are multiplying.
Yeah.
So next you are selecting 2 women out of 3 in these many ways. So this will be multiplication. Very very important.
Yeah,
It need not be addition. Okay.
Yeah.
Very very important. This is we normally tend to make mistake there.
Yeah. Okay.
It is multiplication. So this kind of questions can come. It's very very important. Okay. So I'll just summarize. There are 5 people. Okay. There are 2 men, 3 women. You want to select a group of 3 in which there will be 2 women and there will be 1 man. Okay. So 2 women can be selected out of 3 in 3C2 ways, and 1 man out of 2 can be selected in 2C1 ways. You have to multiply it. So that is the number of ways in which you can form a group of 3 consisting of 2 women and 1 man from a group of 5
people. Understood.
So this is how we have now. This is all about combination. Okay. So you can now practice. Okay. So those tricky things, 4 tricky things, what I have told in permutation, and this last one that I have told, and this numerator.
That
okay.
n minus 8, n minus 9
n minus 8 factorial
produce
this.
n minus 8 into n minus 8.
So if these things you can catch, then it will be easy for you. Okay. So with this we have finished permutations and combinations. Okay. So we'll just quickly go to the binomial theorem. Okay. It's a very simple one. A small and simple one.
That one.
Okay. You stop it. Then.